Did you know Mars's volcano is 72,000 feet tall? That's the size of 2.5 Mount Everests in height, while it's the area of the size of the entire state of Arizona. In the search for more knowledge in the very solar system we live in, we've sent rovers and cameras as far as we can to the moon and even to Mars to discover if Mars, a desert planet, could offer us humans another home. And the most important factor to that is if liquid water could exist, has existed, and may still exist on that planet. Mars is considered the second best habitable planet, second to Earth itself, for a few reasons, one of which being its recently discovered liquid water. Ever since starting this fall semester, I've gotten to learn lots in my geology course, including, but not limited to, how volcanoes are created through plate tectonics, and we even discussed the case of Mars and its volcano, and what that could mean for the history of water on Mars, and the future of humans on Mars. Today, I will inform you of the 3 factors that have been researched to discover whether or not Mars has water, and if it did, where it went, seeing as we can't see it with the naked eye, or at least we can't see liquid water, which I'll get to in a second. First, I'll talk about the existence of volcanoes and what that suggests for the history, and then I will discuss the other geological evidence of water, and then finally I will look at the use of the seismic imaging on Mars for hard facts of what we know. Starting with Olympus Mons. The extinct volcano on Mars, Olympus Mons, suggests that at some point there was an ocean. We know there had to once be an ocean, and we know that there is frozen water on Mars. But what about the massive ocean? Where did all that water went? Where did all that water go? It's not all accounted for by just what we see in the polar ice caps. From what we can see, when we are taking images of Mars, the polar ice caps shrink and grow dramatically, meaning that there isn't much water there. There's very little water there, but definitely not enough for an ocean. Sorry. Volcanoes are formed on Earth through the presence of active tectonic plates and the mixture of an ocean causing disturbances under the crust, causing the active mantle, or that hot stuff, to release magma, and that's what causes a volcano to form and continue to exist actively. Although it's currently extinct, an ocean and active core would need to be present at the same time for that volcano to ever exist. In an article titled Giant Mars Mountain Olympus Mons May Have Once Been a Volcanic Island, Keith Cooper states that according to geological evidence, Olympus Mons may have once been a volcanic island surrounded by an ocean nearly 4 miles or 6 kilometers deep. The evidence for this is found in the shape of the mountain, a shield-shaped volcano with deep curvature on the side that indicate where a shore may have once been. Now that I talked about Olympus Mons, next let me discuss other geological evidence of liquid water. Mars has polar ice caps, but like I said before, they don't account for the water as deep as an ocean. And with geological features like the land where its clear water once flowed in rivers, we know there was a huge amount of water on Mars at some point in its history. Mars has had at least some water in the form of snow or ice at the time. Form of snow or ice. At the time, CO2 ice was not even considered a possibility. We now understand that that is most of what we can see of Mars's ice caps. The caps dramatically expanded and shrank as seasons passed, which suggested that the amount of water was not great. Orbital images of geological features such as the outflow channels and valley network strongly suggest that Mars had been much wetter in the past. Now that we understand all the geological features that show water existed and in large amounts, finally let's examine where it possibly could have gone. We can see that the ground of Mars, its crust, is built up of a porous rock that, with its temperature and pressure level, shows that the water, solid or liquid, is contained, and that it may hold even more than what we previously thought of or assumed with the amount that an ocean would hold. Seismic imaging of Mars starts with the InSight mission, which, as Scott K. Johnson in InSight Data may have revealed water deep below the surface of Mars states, has produced an impressive amount of knowledge from a single seismometer running for just a few years. We've learned about the thickness and composition of Mars's core, mantle, and crust. If there's water, either liquid or ice, below the Martian surface, then that too is part of the picture drawn by the data. From what has been recorded, porous ground, assuming the rock below the insight is representative of the planet, the volume of the liquid water proposed by their model is actually larger than the estimates of Mars's surface oceans. So there's more water than we previously thought, even with the idea that Mars had large oceans. Many of it is possibly underground in the ice caps, and yet we haven't found much of it in the in the atmosphere. Sorry. Lost the time. Signaling. With an understanding of Mars's history of water and the mystery of the missing water, let's begin to wrap up. First, I talked about what the existence of volcanoes suggests, then I discussed the other geological evidence of water, and finally I went into the use of seismic imaging on Mars and what evidence it shows. Mars is a complex planet, much like our own, both in its history and its present day. Someday, it might be our next destination as a civilization. Everything we learned in one lifetime, imagine what's left to discover for the next generation. Thank you so much for listening, and have a good one.